Hello and welcome to SudoKanard. Here's a killer Sudoku that I created a few weeks ago. I published it on my blog and I linked the blog entry in the description and the Pampa link so you can solve it online before watching my solve. Well, actually, it's been a few weeks, and as usual, I've forgotten almost everything I've done during the creation of this puzzle. But I think some stuff is really visible from the start. 10 has only one option, 11 has only one option. So one option is a list of 5 digits, the only decomposition. And let's have a look at this. You can see that those 5 cells must contain digits between 1, 2, 3, 4, 5. So none of them contain 6, 7, 8, 9. So 6, 7, 8, 9 should be in those cells. And you can see that in those 5 cells, 4 has to be in the top 2. So those can't be 4. And 5 has to be in one of those. So this can't be 5. And something similar happens here. You see that those 5 digits are 1, 2, 3, 4, 5. So those 5 digits should be 6, 7, 8, 9. And then you see that among those 4 cells, only this one can contain a 4. And one of those 2 must contain a 5, so there's no 5 here. And down there we have a 10 cage again. So we have 1, 2, 3, 4, 5 into those 4 cells. So this has to 1, 2, 3, 4, sorry. So this has to be a 5. This is not a 5. One of those is a 4, so there's no 4 here. There again, the remaining 4 cells should be 6, 7, 8, 9. And you see that this 30 cage is also 6, 7, 8, 9. And in this box, 4 has to be in one of those 2 cells, which removes 4 as an option here. This is a 4. Is there anything about this? Not that I see. This 29 must be 5, 7, 8, 9. So there's no 6 in this box, and there's a 5 here. There has to be a 6 here, and it removes 6 from both cells there. All right, where should we look now? Those digits have a minimum of 10. So this should have a maximum of 15. That's not very useful, I'm afraid. Where else should I look? 1, 2, 3. So there's a 4 here. There's a 5 here, that's true. I'm not sure where I should look after this. So, could 4 not be here? If 4 is not here, then we have 6, 7, 8, 9, and this has to be 30. So there's definitely a 4 here. The remaining 2 digits should have a sum of 21. And I think the only option is to have this. Yes, that's true. If I try to put a 9 somewhere, I have 4, 9, that's 13. And the remaining 2 digits should have a sum of 12 without using a 4 a 5 or a 3, and that's not possible. So this must be a 4, oh, sorry, a 4, 6, 7, 8 cage. So there's no 9 here, and the candidates are those. So there's definitely a 4 here, sorry, a 4 here, and there's a 9 somewhere there. So I can remove 9 from both cells here. 9 here would be powerful, because it would mean that those 3 cells are 1, 2, and 4. Where else should I look? Perhaps it's here. Wondering where 4 goes. Not sure about that. But what I know for sure is that there is an 8 and a 9 somewhere here. There's also an 8 and a 9 somewhere here, but that's not saying so much. Oh, but yes, this digit here is not in those cells, it's not in those cells. So this digit is somewhere here. Is that useful? I'm not sure that it's useful. And similarly, this digit here is somewhere there. So this digit is somewhere there. And it should be somewhere here as well. Not seeing what it does. And this digit should be somewhere here. Oh, that's what I'm missing. 1, 2, 3. I got a 1, 2, 3 triple in this column, so there's no 1, 2, 3 here. So 1, 2, and 3 must be here. That's geometry. That's not a 3 because it is the one here. And 3 is the minimum value you can put in a 27 cage, so this has to be a 3, and the remaining 3 cells must contain 7, 8, and 9. So that's a 7, 8, 9 triple. There should be a 5 somewhere here, so there should be a 5 somewhere here. And now that's interesting, because there are 2 ways of making 28. One of them is 4, 7, 8, 9. The other one is 5, 6, 8, 9. But 4, 7, 8, 9 here would leave no option for this cell. So this has to be 5, 6, 8, 9. So we know that 5 is here. And there's no 7 here. This is 6, 8, or 9, and this is 7. So those are not 7, and this here is not 8. And the remaining cell here has a 4. There must be a 4 somewhere here. That's not a 5. So we have a 6, 7, 8, 9 triple here. 7 is in one of those 2 cells, so there's no 7 here. And we get a 6, 8, 9 triple here, so there should be a 7 somewhere here, so there's no 7 here, and the 7 in this cage is here. There's a 5 somewhere in one of those 2 cells, not sure where. What next? 4 is not here, so that's a 4. And there's an 8 somewhere here, and this digit is this one, I think. No, sorry. Oh, sorry. 7 here is removed from those cells, so that's a 7. And this is a 9. And I was mentioning it earlier, so that's a 7, sorry. 9 means that the remaining 3 digits are 1, 2, and 4. So there's a 4 somewhere here. There's no 4 here, that's a 4. And this here must be 1, 2, or 3. That's the missing digit from this triple. What next? This 7 makes this an 8, this a 5. So this is no more 5 or 8. This is no more an 8. There's no 8 here. And here, this can only be a 6. This can only be a 9, that's a 7, and that's a 9. This here can only be an 8, so that's not an 8, that's not an 8 either. This is no more an 8. And on this row, we still need 1, 2, 3, and 4. This can only be 1 or 2. This still has 4 options. The options here are 4, 6, and 9, but this can't be 6 or 9, so that's a 4. 6 or 9 here. This is the same as that, and the same as that. Not sure it will be useful. But then we need 21 here, and this is at most 5. It could only be 1, 2, or 5, but 1 and 2 would be too low. So that has to be a 5. And another 16, so that's 7 and 9. Because of this 7, that's a 9, that's a 7. That's 8, that's 9. 6 here, 9 there, and 6 here. 6 here as well. No 6 there. And no 9 in this position. This column still needs 1, 2, and 3. That's not a 3. So we have a 1, 2 pair in this row. This 7 makes this a 6, that's a 7. I still need 1, 2, and 8 in this row, so this can only be 8. And this resolves a few digits. Here we need 5 and 6. Here that's 1 or 2, that's 1 or 2. We have a 1, 2 pair here, so that's a 3. Now, those should be 4 and 8. Oh, 6 and 9. And there I get an 8, that's 6, that's 8, that's 9. There should be an 8, sorry, 8 is here. That's the only place for an 8 in this box, so that's 4, that's 8. That's not a 4, so 4 is here. This can't be a 3, so it has to be 1 or 2, and I get this 3 here. We see that there will be a lot of 1, 2 pairs to disambiguate in the end. That's not a 3 anymore. This is not a 3 anymore. This row, this can only be a 5 now. That's not a 5, that's a 5. Those 7 pencil marks, only this one is possible. The other digits are 1, 2, 3. I get a 1, 2, 3 triple here, so 3 is here, it's not in this cell. In this column, 3 can only be here. 5 has to be here, and this is 6. That's 9. I need another 7. 1 plus 6 is not possible, so it's 2 plus 5. And this 2 should do the trick for the final disambiguation. Oh, sorry about that. 2, 1, 2. That's a 2. That's a 1, 2, 1. That's a 2, that's a 1. That's a 2. This one here puts a 1 here, so that's a 3, that's a 1, a 2 and a 3, 1 and a 3. And that's a 6, that's a 5, and the final digits are a 6 here and a 4 there. Yes, that's it. So to solve this, first you need to know a few standard decompositions, like 10, 11, 29 here, 30 there. And the crucial step was really this 1, 2, 3 triple in this column, because it allowed this 3 to be put in this 27 cage, and the rest was more standard deductions. Thanks for watching this video, and see you soon on SudoKanard. Oh, here.